Hello everyone, welcome to our Spring AI classes. In our previous class, we learned about different models, how it will work, what are the different comparisons, what is MCP, and what is the RAG, how we can implement using Spring AI. Today we are going to learn about one of the concept to building the agents in the Spring AI. What do you mean by agent? Agent is usually it is called whatever the tasks done by human that can be by making use of agent we can complete the task. If you see here in the document, building effective agents, Anthropic shared valuable insights about building effective LLM agents. What makes this research particularly interesting is emphasis on simplicity and composability over complex frameworks. If you see here in the below diagram, Spring AI, it will connect to LLM. For what Spring it will do is, first once you get input, Spring AI will call the retrieval and it will call the tools and it will whatever the data shared in the saved in the memory. Based on that, LLM will process and will get the output. While the pattern description and diagrams are sourced from Anthropic's original publication, here we will focus on how to implement these patterns using Spring AI's feature of models, portability and structured output. So if you see AI system, agentic systems, what it will do, the research publications makes an important architectural distinction between two types of agentic systems, that is workflows and agents. What workflows will do? Systems where LLMs and tools are orchestrated through predefined code. Prospective agents, systems where LLMs dynamically direct their own process and tool usage. Let's examine how Spring AI implement these concepts through 5 fundamental patterns. Chain workflow. What is the chain workflow? The chain workflow pattern examples the principle of breaking down complex tasks into simpler and more manageable steps. First input, what it will go, LLM call 1, then output 1 you will get. There is a gate. Through gate, if it is pass, again it will call the LLM call 2 and output to LLM call 3, then final output. If its gate is failed, then directly it will exit. This is the first pattern, chain workflow. When to use? Task with clear sequential steps when you want to trade latency for higher accuracy when each step builds on the previous step's output. Here is a practical examples how Spring AI implementation. So if you see here chain workflow, response we got, response means user input, prompt system prompts, string dot format prompt comma response. Then chart client, whatever the client we are using, we will call it, then content. Each step has a focused responsibility. Output from one step becomes input for the next. The chain is easily extensible and maintainable because we are using array here, system prompts. Based on the system prompts, then the repetitive will happen. Parallelization workflow. LLMs can work simultaneously on tasks and have their outputs aggregated programmatically. If you see from input, LLM call 1, call 2, call 3, aggregator will be there. Then you will have the output. When we have to use, suppose if we have parallel tasks requiring multiple independent perspectives when processing time is critical and tasks are parallel. This is the suppose what question he asked. Analyze how market changes will impact this stakeholder group. One is customers, employees, investors, suppliers. So these tasks supposed to be done through parallel. In that case, we can use this pattern. Routing workflow. The routing pattern implements intelligent task distribution, enabling specializing handling for different types of input. Suppose first input, LLM call router will be there, then call 1, call 2, call 3. So whatever the response we get output, then it will distribute that to other requests. When to use complex tasks with distinct categories of input, when different inputs require specialized processing, when classification can be handled accurately. If you see here, billing, you are a billing specialist, help resolve billing issues. If you are a technical, you are a technical support engineer, solve technical issues. General, you are a customer service representative, help with general queries. Input is my account was charged twice last week. So these are the independent tasks where output will be to give to the response to the particular customer. Then orchestrator will be there before calling to LLM, then synthesizer, then this is output. When to use complex tasks when where subtasks cannot be predicted upfront. Tasks requiring different approaches or perspectives, situations needing adaptive problem solving. So this is how orchestration workflow will work. Orchestration analyzes tasks and determines subtasks. Then workers process subtasks in parallel. Results are combined into a final response. Generate both technical and user-friendly documentation for REST API endpoint. Analysis, response.analysis, work responses. The another one is evaluator optimizer. This is the diagram. When to use clear evaluation criteria exist. Iterative refinement provides measurable value. Tasks benefit from multiple rounds of critique. Create a Java class implementing a thread safe counter. Then we'll chain of thought will be there, right? So based on the sequence of questions, it will give the response. What is the advantages? Spring AI implementation advantages. Spring AI implementation of these patterns of several benefits align with the Anthropic recommendations. This about the dependency, where do we will use it? This is the structured output. Consistency API, uniform interface across different LLM providers, built-in error handling retrace, flexible prompt management. So before starting to implement any agent, start simple, begin with basic workflows before adding complexity, use of simplest pattern that meets your requirements, add sophistication only we needed, design of reliability, implement clear error handling, use type safe responses where possible, build in validation at each step, consider trade-offs. So these about the basic concept how we can implement effective agents. So same question I asked in ChatGPT. So what I asked, how we can building effective agents using Spring AI and Anthropic LLM. So what it is given, what is an AI agent in Spring AI? AI agent is more than a chart model. It can reason, LLM Claude, use tools, Java methods, APIs, DB queries, plan and act, decide next steps, maintain context, memory, achieve goals, task-oriented behavior. Spring AI provides LLM abstraction, tool function calling, memory prompt management, easy Spring Boot integration. This we already learned in the previously. Why Anthropic Claude with Spring AI? It is for strong reasoning, large context window, safer and more controllable outputs, excellent tool use patterns. These are the different models which Claude provides. High level architecture. Suppose in user UI or API, Spring Boot agent orchestrator, then it will call the Spring AI, Anthropic LLM for reasoning, tools that is called DB REST or files, comma search, memory conversation for vector or DB. These are the Maven dependencies where we'll use Spring Boot starter for Spring AI core. This is how we'll configure the Anthropic API key, which model we are going to use, what is the temperature, we'll configure that. So if you see here, define the agent, prompt, role plus goal. What is the uh, prompt, you are a smart enterprise agent. Your goal is answer your queries by reasoning, calling tool when required, and providing accurate results. This is the prompt we have given. So here if you see tools we have created, one of the tool is get account. If user provides account number, what we have to do is account number active and what is the balance, get account details by account number. This is the tool calling. So Spring AI automatically exposes to this cloud. What orchestration service? Agent service will call the your enterprise agent default system, then run agent. What is the status of the account? 12345. Suppose user asked, agent thought, the Claude, I need account data. Call get account tool. It will get the tool call get account number. Then final answer will be account is 1235 active with a balance of 25,000. How will add it to the memory? In memory, a chat memory is there. There is an interface. Uh, we can write one call. It will call the new memory chat memory attached to the chat clients to maintain state across calls. So how we can do multi-step agent? First plan it, act it, observe. How our design should be: understand the task, decide which tool to use, execute the tool, verify output, respond to the user. What are the real world use cases for using this agentic? Banking, account inquiry agent, fraud analysis agent, loan eligibility agent. In ESG cases, a document question and answer agent using RAG, a rule inappropriation agent, DevOps, suppose if you want to use agent, in incident triage agent, log analysis agent, enterprise knowledge, policy assistant, HR IT help desk agent. So what are the best practices? Use low temperature, keep tools small and focused, separate reasoning prompt and output format, add guardrails in system prompt, log tool calls for audit, use RAG when knowledge is external. Difference between agent versus chatbot. Reasoning, chatbot does not have reasoning, agent will have. Tool usage, agent. Multi-step actions, yes. Enterprise tasks. This about the how we can work using Spring AI and implement the small agent. Thank you for watching. Have a great day.